What's up, guys? It is Mr. Meehan. We're talking about Unit 3, Lesson 4, which says, I can describe a figure before and after a series of composition of rigid motions. We're going right into a problem. The problem states given triangle XYZ with vertices X, Y, and Z, and then triangle X double prime, Y double prime, Z double prime with vertices X double prime, Y double prime, Z double prime. Find a series of rigid motions that transforms the pre-image to the image. The first thing we're going to do is graph the original points it gives us, and I'm going to do that in blue. So let's do x at -3 up 7. That's x. Y is at -2 up 1. That's y. And z is at -5, 8, 7, 6, 5 up 2. That's z. And then connect those points to make a triangle. We then can graph our double prime points, and I'm going to do that in red. So x double prime is at 6, 8, 7, 6, -5, 1, 2, 3, 4, 5. That's x double prime. All right. Y double prime is at 7, 1. And z double prime is at 4, 0. 1, 2, 3, 4. There we go. So we're trying to go from the blue shape to the red shape. How can we do that? Let's try to get the orientation in the correct position. So maybe we could, let's say there's a line like the x-axis there. If we reflected the blue shape across the x-axis, what would that look like? It looks like we would have a point, let's call it y prime, at -2, -1. Let's call it x prime at, I believe, -7. Sorry, -3, -7. That's right. And then z is at -5, -2. That's z prime. And we can connect those dots. So I'm calling this green shape just the prime shape. So like triangle x prime, y prime, z prime, because it's the shape that's in between the blue original shape and then the red double prime shape, okay? So that's why I kind of made the prime in the middle, okay? So we now have the orientation correct in, I guess, let's say step 1, we reflected it across the x-axis. Okay? Let's try to figure out step 2. Step 2 is how do we get from the green shape to the red shape? So let's kind of pick a point here. I'm going to do this in light blue. Let's pick a point here. Let's say x prime and x double prime. How do we go from x prime to x double prime? Well, the x values, it looks like we go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like we are translating it. Let's say we say xy turns into x plus 9. I believe we just counted 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. And then we are going up 2. Okay. So y plus 2. So since we found that that translation takes us from x prime to x double prime, it'll work like that for all the points. It'll work for z prime and z double prime, y prime and y double prime. So to go back to the original question, how do we get from the blue shape to the red shape? Well, we first do the step of a reflection over the x-axis, and then we do the step of translating it to the right 9 and then up 2. And this, when we combine a series of rigid motions, like a reflection and a translation, this is called a composition of rigid motions. So that's what this lesson is about. This brings us into the composition of rigid motions theorem. This says the composition of 2 or more rigid motions is a rigid motion. So when you apply 2 rigid motions to one shape, then you can count those 2 rigid motions as a single rigid motion. So if you look on the left, it says if you do a reflection, then a translation, just like we just did. This is the exact rigid motions that we just did above. Then it can count as a single rigid motion, and it's written like this on the right. And you read this, you might notice right to left, right to left. So this says first do the reflection over the x-axis, and then second do the translation, okay? And then this dot in the middle, this kind of circle, is just kind of like a mathematical operator. In this scenario, just treat it like an and symbol. So you read this right to left, so you say do the reflection first, and then do the translation. That's what it should say. All right, so this example here. So we just learned about what a composition of rigid motions is. Now let's learn how to use it in an example. This example says, what composition of rigid motions translates triangle ABC to A prime, B prime, C prime? So we're trying to go from the black triangle to the orange triangle. I think the best first step is try to get the black triangle into the proper orientation, and then we can kind of translate it into position probably. So what if for our first step, we did a reflection over the y-axis like this? That would mean our A, now instead of being -5 up 1, it's not going to be +5 up 1. And then B is going to, instead of being -3 up 4, now it's going to be +3 up 4. That's B. And then C is going to be, instead of -3 up 1, now +3 up 1. All right, and you can connect those dots. And this is just kind of like a filler shape. It's not really there. We're just using it for our reference. All right, so step 1, we reflected it over the y-axis. Now step 2, how can we go from the green shape to the orange shape? Well, let's pick a point here. Let's say we pick point C. How do we go from our green ghost C to the orange C prime? All right, looks like we can go to the left, 1, 2, and then down 1, 2, 3, 4, 5. So it looks like we're gonna go x minus 2, and then what is it? Down 5, we said. Down y minus 5. So the composition of rigid motions that we have are first to do a reflection over the y-axis, and then second to go left 2 and down 5. But again, up here in the composition of rigid motions theorem, it says that we should write it with this operator, and we should make it in one step, so it's not 2 steps. So to do that, remember we're supposed to read the compositions of rigid motions right to left. So our reflection over the y-axis is going to be on the right side, y-axis. And then we'll put our operator, which is kind of like an and sign, and then we'll say x minus 2. Actually, let's do it in the shorthand notation or whatever, right? So the translation, minus 2 minus 5, and that's on triangle ABC, and that becomes triangle A prime, B prime, C prime. All right, so our full composition of rigid motions would be written like that. A little note here, this says the composition of a reflection followed by a translation is called a glide reflection. Glide reflection. So that, it just has a name because it happens so often. Mathematicians of the world gave it a name. And that's exactly what we did up here. We did a reflection first and then a translation. So what we did is a glide reflection. That's a glide reflection. So let's go down here. It says example, quadrilateral, that's a 4-sided shape. RSTV has vertices R, S, T, and V. Use the rule of a reflection over the x-axis and then a translation 1, 0 to graph and label the glide reflection of RSTV. So remember, we're reading this right to left. I think the best way to start this is to graph our points R, S, T, and V. I'm going to do that in dark blue. R is at -3, 1, 2, 3, up 2. That's R. S is at 0, 5, 1, 2, 3, 4, 5. T is at 1, 2, 3, 4. Down 4, 1, 2, 3, 4. And V is at 0, -2. Let's connect our dots. And then there we go. Our next step is to do, so this is our original shape. So what we have to do now is first reflect it over the y-axis, sorry, x-axis, reflect it over the x-axis, and then do the translation, okay? So I'm going to do the reflection over the x-axis. We're going to apply that reflection to all of these coordinates up here, okay? So I'm going to do the reflection over the x-axis in green, to be more specific. So if we're to apply the reflection over the x-axis onto those coordinates, you have to remember the rule for the reflection over the x-axis. That states, what does it state? It's xy becomes x comma negative y. All right, so you take the opposite of all the y values. So our in-between shape would have the coordinates -3, -2, 0, -5, and 4, 4, and then 0, 2. Okay, that's the coordinates of our in-between shape. And we could graph that if we wanted to, but I'm not going to right now since it's the in-between shape and I don't want to make our graph all messy. So the next step here is to apply the translation 1, 0, and we're applying that to all the points in green that we just wrote down. So what we're doing is we just did the reflection, and now we're applying the translation as well, but to the points that we just created. So what are we going to do? It looks like we're just adding 1 to all the x values. So t prime, because this is our final position of these points, so this will be the prime position. T prime is going to be add 1 to -3, it's -2, -2. That's actually r prime, not t prime, my bad. S prime is then going to be add 1 to 0, you'll get 1, -5. T prime is then going to be add 1 to 4, you get 5, 4. And V prime is then going to be 1, 2. So then can we graph those points? I'm sure we can. We'll get R prime at -2, -2. We'll get S prime at 1, -5, 1, 2, 3, 4, 5. T prime at 5, -4, no, 5, +4, 1, 2, 3, 4, 5, 1, 2, 3, 4. That's T prime. And V prime at 1, 2, 1, 2. So if you connect those dots, we can go from the blue to the red by that composition of rigid motions. Here's an interesting theorem. It says, what is a rigid motion theorem? It says any rigid motion has to be either a reflection, rotation, translation, or a glide reflection, what we just learned about. And a glide reflection, again, is a reflection followed by a translation. Glide reflection. All right. So if M is a rigid motion, then it has to be either a reflection, translation, rotation, or a glide reflection, a reflection followed by a translation. That's all it states. Those are the only 4 rigid motions that there is. Okay? What is a rigid motion corollary? A corollary is just kind of like an addition to a theorem. It's similar to a theorem, kind of. It says any rigid motion can be expressed as a composition of reflections. Reflections. What this states is if M is a rigid motion, then M could be 1 reflection, 2 reflections, 3 reflections. It could be infinite reflections, right? However many reflections that you need to make the rigid motion work. No matter what the rigid motion is, it can always be expressed in a number of reflections. All right, what is the glide reflection that maps triangle JKL to J prime K prime L prime? Again, a glide reflection is a reflection followed by a translation. So let's do the reflection first. I would say if we were to do a reflection first, I think the best way to do it would be reflect it over the x-axis. And if we did that, our in-between shape would kind of be right there. There's J, because J's at -5, -2, so it would be -5, +2. And then L would be, instead of at -3, -2, it's now -3, +2. That's L. And then K, instead of being at -2, +3, it's now at -2, -3. Let me make that a little more clear. There we go. So all I did was do a reflection over the x-axis. Let's kind of write that down. Reflection over the x-axis. Second step, we have to do a translation from something to something, from the green shape to the orange shape. Let's see, how do we go from J to J prime? Let's see, if we go over to the right 1, 2, 3, 4, 5, and then up 1, 2, that'll get us there. So let's say our second step, translation 5, 2. And that's applied on triangle JKL, which will give us then triangle J prime, K prime, L prime. So our next example, our last example here, we're talking about glide reflections one more time just to get the practice down. It says, what is the glide reflection that maps triangle ABC to A prime, B prime, C prime? Let's start this by graphing the original coordinates in blue. So A is at -3, up 4. There's A. B is at -4, up 2. There's B. And C is at -1, +1. There's C. And then in red, I'm going to graph our new coordinates, our image coordinates, right? A prime is at 1, 1. B prime is at 2, -1. And C prime is at -1, -2. Interesting. Now we're trying to use a glide reflection to get from the blue shape to the red shape. And a glide reflection is a reflection followed by a translation. So what reflection would help us get there? I think probably a reflection over the y-axis. So if we did that, I think C prime would kind of be where A prime is. I guess let's just call it C right now, since it's not really there, right? It's kind of our ghost shape. It's our in-between shape. So C, our green C, is right there. B would then be at 1, 2, 3, 4, up 2. There's B. And A would then be at 3, 4. All right. So there's our green shape. And that's step 1. So let's kind of write it like that. Reflection over the y-axis was step 1. Step 2, we know it has to be a translation. So how could we translate this green shape to the red shape? Let's see. If we look at point A, it looks like we go to the left 2, and then down 1, 2, 3 to get to A prime. And that would work for all the coordinates. So our translation would be -2, -3, just like that. -2, -3. And that's being applied to triangle ABC, which will give us triangle A prime, B prime, C prime. And that's how you do a glide reflection.